In today's lesson, we are going to be looking at working with fractions. Again, this might be something that you are already familiar with. Hopefully it's something you've looked at before, so maybe you just need a little bit of review. But again, hopefully fractions aren't entirely new to you. And we're going to be looking at adding, subtracting, multiplying, and dividing fractions. So just as a little warm-up, and we'll do this in class, the math department is having a bake sale. Wanting to be different, they cut the cakes into different sized slices. If a whole cake costs $10, what is the cost of each slice? So here's the first cake, and I'll walk through the first one, then I'll show you the other ones, and you can try this on your own as a warm-up. So for the first cake, right, we can see that we've cut it up into 4 slices. Right, and by the looks of it, it is 4 equal slices. So each piece of cake is 1/4 of the entire cake. So if that's the case, each slice then would be 1/4 of $10. So I can take $10, divide it by 4, or write it as a fraction, means the same thing. 10 divided by 4, which gives me 2.25. Or, I'm going to write it maybe as a mixed fraction, 2 and not 2.25. Wow, can't do my math. 250, 2 2/4, or 2 1/2. So different ways you can represent it, but if we're dealing with money, it's fine to use decimals. So each slice here would be $2.50. I'm going to give you different examples or different cuts, and I want you to try to determine what the cost of each slice is. Next one. So now we're dividing it up into 3. We have another one, dividing it now into triangles, 3 different triangles. Does it change from the last one? Is it the same? Different cuts. Another one, 2 slices. Here we have 3 slices, but now their shapes are getting a little bit more different. And we're getting more unique in some of our shapes. Another unique one. Getting some smaller slices now. This one might be a little difficult to see on mine. It's a little bit easier. I'll draw the lines in. Assume that everything's straight and nice and neat. Right, those are the different slices. And then last but not least, we have these 2. And then finally, the most slices, we want to figure out what is the slice or the cost of each cake, or each slice. Again, assuming the entire one is $10. So with this, we're going to need to work with fractions. Right, so this is a little bit of a warm-up to get you comfortable with fractions, breaking fractions down into some simpler terms, or dividing fractions or breaking them down even further. So we're going to start with adding and subtracting fractions. And when adding and subtracting fractions, one, it depends on what we're dealing with. Ideally, we're dealing with either proper or improper fractions. But if we're dealing with mixed fractions, right, which means we have whole numbers and a fraction. If we're dealing with mixed fractions, we add and subtract the whole numbers first. So we can just take the whole numbers, remove them from the situation, add or subtract them first, and then deal with the actual fraction part. When adding and subtracting or subtracting fractions, we need common denominators. So we need to make sure that the lower number or the bottom number of the fraction is the same. In some cases, we might have to change a fraction by multiplying or dividing to make it larger. Ideally, it would be nice if the denominators were always the same, but that's not going to be the case. And then once we have common denominators, we only add or subtract the numerators. So we only deal with the numerators after we have a common denominator. We don't add the bottom numbers together. Right, so let's solve the following and express the answers in simplest form. So the first one, 1/3 plus 5/3. So now here we have a common denominator. That's great. That means we don't have to change our fractions at all. Because they have common denominators, the denominator is going to stay the same. It's going to be a 3. I can add my two top numbers, 1 plus 5, which gives me 6. I can reduce this to simpler terms, right? Remember, a fraction just basically means division. So this is the same thing as saying 6 divided by 3. And I can do the division here because it's going to work out to a nice number. Because 6/3 is the same as saying 6 divided by 3 or 2. It gives me a nice whole number. If it didn't give me a whole number, I probably wouldn't divide it. I would leave it as the fraction. I might convert it to a mixed fraction, or I might leave it as an improper fraction. Either way is fine. But we generally will be looking at improper fractions later on in the course. That doesn't mean that we aren't going to be dealing with mixed ones later on. You might see something like that on EQAO, things like that. So it doesn't hurt to remember what they are. Next, we're subtracting. So -3/4 minus 1/5. I'm subtracting these two fractions. However, my denominators are different. So that means I have to change them. And if I'm going to change them, I need to multiply both the numerator and the denominator by something. And a helpful tip, if they're not even close, or if I don't multiply just one to get to the other, right? I take the denominator of 1 and multiply the entire other fraction by that, take the denominator of 1 and vice versa. So I'm not going to do that because that looks like cross multiplying, but I'm going to take the -3/4. I'm going to multiply the entire thing by 4. It means I multiply the top by, or not by 4, sorry, by 5, which is the denominator of the bottom. Both parts. Right? I need to keep it the same. So this gets me -15/20. For my second fraction, 1/5, I'm going to multiply everything by 4. So this will give me 4/20. Now I can go through and subtract. So -15/20 minus 4/20. Actually, let me kind of color code this a bit more. So now the denominator is the same, so it's going to stay as -20. -15 minus 4 is -19. So -19/20 is my simplified fraction. Can I make any changes to this, or can I write it in simpler terms? I can't. Right? There's nothing I can divide both -19 and 20 by. So this is as small as it's going to go. So that would be kind of a complicated case where we had to change the denominators of both fractions. Just reorganize this a bit. Additionally, you might have said, well, in the first one, right, why did you make the 3 negative? Well, we had talked about before in a previous lesson, it doesn't really matter which one is which. It might have been in this class, I can't quite remember. But when we have a minus in front of the fraction, it doesn't really matter which part it applies to, either the numerator or the denominator, as long as it only goes to 1. Right? And the reason being, I'll just do this as a little aside, if I did -3, let me use a different color. If I did -3/4, right, divide that, I would get -0.75. If I did 3 divided by -4, I would get the same thing, 0.75. So whether the negative is on top or on the bottom, I still get the same answer. However, because the negative is out front, in the middle, that means that my overall fraction is negative. So if I was to add a negative to both the top and the bottom, I would actually get positive 0.75, which is not a negative number. But the negative out front indicates that we do have a negative number. So that means that I cannot do this where I have both a negative on the numerator and the denominator. So if we see the negative in the middle, let me write this out a little bit. Negative sign in middle means that it could be either negative 3 over 4 or 3 over negative 4. Now, generally speaking, it would be helpful, or it is a little bit easier if we add the negative to the numerator. It saves us a little bit of hassle when we're trying to find equivalent fractions. So I would always apply the minus or the negative sign to the top number, but technically you could add it to either. For C, here we have mixed fractions. So now we have to do something a little bit different. First, let's simplify this double sign. So 3 2/3 plus a negative is the same thing as saying minus. So minus 1 3/4. With my mixed fraction, I'm going to deal with the whole numbers first. Right, so off to the side, 3 minus 1 equals 2. And then I'm going to next deal with just the fractions. So 2 over 3 minus 3 over 4. It's still going to be subtraction. I'm still subtracting. I need to get a common denominator. So I'm going to take the 2/3, multiply everything by 4. So multiply by 4, multiply by 4. I get negative 8 over 12. And then my other one, so I have 3 over 4. I'm going to multiply everything by 3, or the denominator of the other fraction, or 9 over 12. Now I can rewrite them. Negative 8 over 12 minus 9 over 12. I have negative 8 minus 9 is negative 17 over 12. And now what I can do is combine both parts, right? So therefore, at the end, I have 2 and negative 17 over 12. You could also convert everything to a improper fraction, right? So you could go through and do the same thing. So you could say, or you could do 3 times 3 plus 2, 11 over 3 minus 4 times 1 is 4 plus 3 is 7 over 4. So you could do that as well, and you should get the same answer, which would be or this makes it a little bit more difficult. So I actually have to go back down here and simplify this a little bit further, because this would be 2 and negative 17 twelfths, or 2 minus this gets a little bit more confusing. It would be easier just to convert it to an improper fraction first, because it's going to save us a little bit of hassle, because 24 over 12 is the same thing as 2, and then minus the 17 over 12. So this ends up being 7 over 12. 7 twelfths. So it would be a little bit easier. And if we were to go through and do it the same way, we should get the same answer. And actually looking at this, I'm going to have to go back and make a few changes. So I mentioned before in the previous lesson how making just a small error with positive and negative numbers always happens. Right? I made this a negative 2 for some reason. Should be a positive 2. Again, not sure why I did that. Right? So again, always make sure you double check your positive and negatives because it could come through and give you a wrong answer. So 8 over 12 minus 9 over 12 gives us negative 1 over 12. So that makes it a little bit easier. I still have to go through and make a like terms at the end or common denominators. So 2 is the same thing as 24 over 12 minus 1 over 12 is 23 over 12. So this 2 over 24 over 12 came from the 2. And this came from here. It was negative 23 over 12 or 1 and 11 twelfths. So again, either way, this one would probably be, it probably in the long run is easier to go through and work with improper fractions because it saves you kind of like having to make the same denominator at the end anyways. But either way, in the end, you should still get the same answer, whether you go through, if I were to convert this one to 44 over 12 minus 21 over 12, we get 23 over 12 as well. So either way, you kind of go through and do it, is up to you. So try to go through these ones on your own. Right? You're going to recommend you pause the video, try to go through and add or subtract these fractions and see what you get. So if you work through these are what our answers should be. So the first one, we should get 3 over 11, right? Common denominator, so we don't have to do anything other than work with our numerators. For B, we should end up with 3 over 8. In this case, we only have to change one of the fractions because I can multiply 4 by 2 to get to 8. I have to do the same thing to the numerator. So 1/4 is the same thing as 2/8. I should end up with 3/8. For C, in this case, I converted both to improper fractions first, and then I went through and found a common denominator. Again, if you wanted to, you could add up the whole numbers first and then work with the fractions. That's up to you. And we should end up with 53 over 15 or 3 8/15, which we then can't reduce any further. With multiplying and dividing fractions, if we are dealing with mixed fractions, here you want to convert to improper fractions. So you want to write them as improper fractions. Again, I think looking at the last examples, I would probably say it's probably better off just to always work with either improper fractions or proper fractions. Mixed fractions can be a little bit complicated, and you would still have to kind of do an extra step anyways. When multiplying fractions, we multiply the numerators together and multiply the denominators together. So the top numbers multiply, the bottom numbers multiply. When dividing fractions, you multiply by the reciprocal. And the reciprocal just basically means you flip the second fraction. And we'll look at some examples of that. But we flip the second fractions and then we multiply. So really, multiplying and dividing fractions requires us to multiply in both cases. So let's go through some examples. So we want to multiply 3 over 4 times negative 2 over 3. We had mentioned before that when we have the minus in front or the negative in front, it doesn't really matter which number it applies to as long as it's only 1. I'm going to apply it to the top number, so negative 2 over positive 3. And when I'm multiplying these fractions, it's the same thing as saying 3 times negative 2 divided by 4 times 3, which would be negative 6 over 12. And I could reduce that to negative 1/2. I can reduce it to negative 1/2 because both numbers can be divided by 6. So similar to before, how we were multiplying both parts by the same number, if we can divide both parts by the same number, we can do that as well. B, 4 divided by 2/3. Now this one might be a little bit tricky because 4 is a whole number. So how can I turn any whole number into a fraction? Well, what I can do, any whole number as a fraction is always going to be over 1. So this would be the same thing as saying 4 over 1 divided by 2 over 3. And what we just said, if we're dividing by a fraction, or if we're dividing fractions, we want to flip the second fraction. So instead of 2/3, it becomes 3 over 2, and we multiply now. So 4 times 3 is 12, 1 times 2 is 2. I can actually just divide these. 12 divided by 2 gives me 6. Again, if it's an improper fraction, try dividing the two numbers. See if you get a whole number. If you can, that's what you can simplify it to. Otherwise, you might have to convert it to a mixed fraction or reduce it. The last one, we're dividing again, but we have mixed fractions, so we need to convert this to improper fractions. And again, when we convert, or how we convert, we do the numerator or the denominator times the whole number, and then we add the numerator. It looks like the same thing. So we'll say add, and we multiply. So 2 times negative 1 is negative 2. Or actually, no, we don't multiply by the negative fraction or the negative number. We just multiply by the number. Because if I did negative 1 plus 1 or negative 2 plus 1, that leaves me back at negative 1. But it's saying I have a whole fraction. So 2 times 1 is 2, plus 1 is 3. The negative carries through, so it's a negative 3 over 2. Divided by, it's going to be a negative number, so 4 times 2 is 8, plus 3 is 11, so negative 11 over 4. Because I'm dividing, I flip the second fraction. It becomes 4 over negative 11, and instead of division, it is now multiplication. I multiply straight across. Negative 3 times 4 is negative 12. 2 times negative 11 is negative 22. I can simplify because both numbers will divide by 2. I get 6 over 11, or negative 6 over negative 11. A negative over a negative will also cancel out. So I can just write it as 6 over 11. That is multiplying and dividing fractions. So try to do these three on your own. Again, same idea. You might have to convert like we did in the last one, but pause the video, try to solve these ones on your own. So coming back with our answers, we should have for A, 1/15. Right, this one is just straightforward. A negative fraction times a negative should give us a final answer that's a positive. 2 over 30 can reduce to 1/15. For B, we're flipping the second fraction and changing it to multiplication. We get 6 over 8, which can reduce to 3 over 4. And for the last one, we have to convert it to improper fractions. So negative 17 over 8 divided by 5 over 4. Flip the second fraction and multiply. We should end up with negative 68 over 40, which can reduce to 17 over 10, or 1 7/10. So again, just kind of going through the different scenarios that we had looked at together previously. One last question, more of a word-based question scenario. So the carpenter has 64 feet of baseboard. She installs 1/2 of the baseboard in one room and 3/4 of the remaining baseboard in the other room. how many feet of baseboard does the carpenter have left? So when we're working with fractions like this, if we want to figure out what half of a number is, or half of 64, I can just take 64 and multiply it by 1/2. That's our first step. 64 and half first. We use half first. So 64 times 1/2. 64 as a fraction is 64 over 1. I get 64 over 2, or 64 divided by 2, which is 32. So therefore, 32 feet in the first room. Next, there's 3/4 of the remaining baseboard in the other room. So if she uses 3/4 in the other room, I can take, there's 32 remaining, because there's 34 feet in the first room, there's 32 feet remaining, or half is remaining. So I can do 32 times 3/4, and I end up with 32 times 3 is 96 divided by 4 over 4, which is 24. So therefore, 24 feet is used in the second room. So that means then all the way at the very end, so therefore, or if I did 64 minus 32 minus 24, I end up with 8 feet. So therefore, there's 8 feet remaining. So again, the main thing that we looked at today was just understanding how to work with fractions, how to multiply fractions, how to add fractions, and how to divide fractions. Just make sure you're comfortable with working with fractions, or if anything, make sure you're comfortable using your calculator.